All right, so this is just an example of what not to do and why. Okay, if we have radical x plus 1 is equal to, let's just say 6, and I want to go through and I want to solve for x, the correct approach is obviously to isolate the radical, right? I want to make sure we understand why. Because if we don't, this is what's going to happen. You're going to square this side and square that side. Okay, now, people that make that mistake are generally of the mindset that when I square the left-hand side, I'm going to get x plus 1. Okay? But if I really pay attention to what squaring a binomial means, it turns into this. Doesn't it? Okay? So even though I'm talking about why we don't do this, the people that do generally do it for 2 reasons. One, they know they need to get rid of the radical, but 2, they don't remember that a plus b squared is equal to a squared plus 2ab plus b squared, that algebra concept from Algebra 1. Okay? If I get down here, I'm going to do first times first, which is going to be just x. But then outside times outside and inside times inside, and when I add those, I'm going to get 2 radical x's, right? And then last times last gives me 1, was equal to 36. What was the purpose of this squaring here at the beginning? It was to get rid of the radical, right? Well, if I do the correct algebra and understand I got binomial squared and what that means to me, do I end up dissolving that radical?
Nope.
No. I actually made it more complex, didn't I?
Yep.
Okay, so that's why we had to isolate the radical every single time. If you don't, you're going to run into an issue like that, or you should run into an issue like that. Okay? So let's go back to this question we did yesterday, and this is, I tried to show that at the end of the class yesterday with this garbage here. Everything's kind of lagging today. I don't know what the deal is, but I want to do that same problem right here, but I want to, instead of saying 5, I want to be negative 5.
Maybe one where it's like 3 and then radical. It's like, I got one where it was like 3 radical signs.
Mm-hmm.
X equals 27. And the answer was not 0. Okay.
So if I make this negative 5, is equal to square root of 4x minus 3. Now, because the square root is already there, that's part of the problem. The sign out in front of it is an understood positive, correct? There is only a plus or negative aspect to roots when you introduce them into the problem, okay? I've had in the past many people get an answer here and then think, okay, well, there's supposed to be a plus or minus thing. I need to add that in. I'm not sure what I'm doing, but I know we talk about that all the time, plus or minus for square roots. So let's just put our answer and then it's opposite. That does not happen here. The root there is already positive, and that's all we've got to worry about, okay? So now if I square both sides, that's going to give me 25 again, right? Over here, it's going to give me 4x minus 3. Is that the same equation right there? So am I still going to get x to be 7? Now here's my question. Is that the answer? So when I plug this in right here, you're going to get negative 5 is equal to 4 times 7 minus 3, which is 25, which is now negative 5. What's the square root of 25? 5. What kind of statement is that? Negative 5 equals 5. False statement. So is 7 a solution? No. So if 7 is not a solution, do I have a solution here? No. Okay. Eventually, we'll get down to the process of graphing these and understanding what a root graph looks like. Okay. But this root graph is going to probably look a little bit like that. Okay. And then negative 5 is a horizontal line through negative 5, right? Do those two curves intersect? No. So does it make sense that we got no solution? Yeah. Okay. So that's the idea about college algebra. Now, it may be a little bit different than algebra, is that you're going to get problems where you have to think about them on kind of different levels. You have to think about them maybe algebraically, okay, and go through the analytical approach and get a solution. But then at the same time, you want to be thinking about it graphically, okay? And if you can do that, if you can look at them graphically before you go through the algebra, okay, hopefully in about 2 or 3 months, we can look at this and automatically say no solution, okay, without having to do anything, because we know that this is the graph that's existing behind the scenes, okay? Folks, I would like you not to be working on something else. So example 2, that 2x equals 1 minus root 2 minus x, okay? What do I need to do here first? I'm going to isolate the radical, right? Okay. So I'm at 2x minus 1 is equal to negative root 2 minus x. When you do these problems, guys, when you isolate the radical, it might be kind of a little bit contrary to the phrase isolate, what we mean by that, because we're allowed to actually leave a coefficient out in front of the radical or a multiple out in front of the radical. So if I want to leave that negative 1 out there, I can. Okay, I don't need to divide both sides by it. All right. If you want to multiply both sides by negative 1 or divide it by negative 1, by all means do it. Okay. You're going to get the same thing. I'm going to go ahead and leave it there and square both sides right away. I square that and then square that. Okay. Squaring the left-hand side, we get 4x squared minus 4x plus 1, right? Looking at the right-hand side, a negative times a negative is a positive. A root times a root gives me the radicand, right? As long as those roots are the same. So this is going to give me 2 minus x. And this stage right here, this is the reason we spent 4 or 5 days on solving quadratics. Because in order to solve this radical equation, you transform it into a quadratic, and now we got to focus on those ideas, those concepts. So we're going to add x to both sides. 4x squared minus 3x. Okay. And then subtract 2 from both sides, so I get negative 1 is equal to 0. When I have something like that, what am I going to try to use first? I'm going to try to use the AC method. Okay, at least that's what it comes down to. Maybe first I try GCF, but there is not one there. So the AC method says A times C should equal negative 4. What are the two numbers then I'm going to use? Multiply together, give me negative 4. Add to give me negative 3. Negative 4, positive 1, right? So then we'll take this up here, and we'll get 4x squared minus 4x plus 1x minus 1. What do these both have in common? 4x. What do these both have in common? 1. And then we get 4x plus 1, x minus 1, x in will be negative 1/4, and x will be positive 1. Is that right? Are we done? No, we're only about halfway done. Even though we got solutions, only about halfway done because we need to see if those solutions are actually valid for the original problem. So we need to bring that stuff up here and check. So I need to put 2 times negative 1/4 in. So I'm just plugging in to this equation. Equals 1 minus the root 2 minus negative 1/4. So on the left-hand side, that gives me negative 1/2. On the right-hand side, I get 1 minus. Now this turns this up. To find the square root of 2 plus 1/4, then we'll change that into a mixed number, 2 1/4, and then change that into an improper fraction, which turns into 9/4. What's the square root of 9/4? Yes. Okay. We all right with that? So 2 plus 1/4 turns into 2 1/4, right? Rewrite that as 9/4, right? It's under the radical, right? If it's under the radical, we can do this, right? Square root of 9 is 3. Square root of 4 is 2. So now what's 1 minus 3/2? Negative 1/2. Is that a true statement?
Sure.
Yes. So that tells me negative 1/4 is an answer. When you're working with extraneous solutions, trying to solve for some extraneous solutions, just because one of them works does not mean the other one does not work. Just because one does not work does not mean the next one works. Does that make sense? You have to individually check every one of them. So now I'm going to try 1. So trying 1, I get I would get 2 times 1, and then I would get 1 minus, 2 minus 1. So I get 2 here, 1 minus the square root of 1. That gives me 2 equals 0, right? That's false. So 1 is extraneous. Okay, if we were to graph these things, the curves that are introduced by the squaring technique introduce an extra solution. Yes?
How come in the beginning, in here, you had 2 minus x, but then up there and up right there, 2 plus?
When I go 2 plus 1/4?
Yeah.
Because 1/4 was negative, so it's 2 minus negative 1/4.
Oh.
If we were to graph these guys, I just want, because I think this is important to see all the time. Okay, as many times as we can see this early on, it's just going to reinforce the ideas. Okay, so if I have 2x and 1 minus the root 2 minus x, so that's the original problem, right? And when we have that original problem, we see that point A is the intersection, and the solution is negative 1/4. Okay? Now, if I were to take, I think this will work writing it this way, f of x, and I square it, so I get that. That is what ends up being the 4x squared. Actually, let's do this. Let's go, I don't want to, that's not going to work, because I need to isolate. So let's go 2x minus 1, and I square that. And let's put that in the right-hand side. And then if I take the 2 minus x that we end up with, come on, 2 minus x, okay? So this stuff here on the right-hand side, what that is a graph of is this right here. Is that okay with everybody? It's after we've squared things. If I wanted to, I could have typed this one in here, but I just want to do the most kind of deliberate one. Okay? I'm going to graph that, and we see then that now there's two intersection points, right? If I look at those two intersections, B and C, right here, is one of them negative 1/4? Yeah, and that's the answer that is showing up over here, right? So what I want you to know is that all of the answers, all of the intersection points that exist over here will indeed be intersection points over here. But all of these intersection points will not be over here. Does that make sense? Okay? You develop extraneous solutions, so you need to check them. Okay? The easiest way, so we went through all that algebra by hand, right, to check them. And I think that stuff in red, that work might even be, I don't think it's as rigorous, but it might have been as time-consuming as actually solving for x equals negative 1/4 and x equals 1. If you want to expedite that a little bit, if you want to do a little bit of work with Desmos or GeoGebra or your TIA 384, you can, and it's not all that difficult. Okay, I'm going to use Desmos. I think I like GeoGebra does so much more, but I think you guys probably would prefer Desmos because of the user interface. Okay, it's just a little bit cleaner to use. So I'm going to just type in 2x, the left-hand side of the original equation, and you want to type in the right-hand side of the equation, which was 1 minus the square root of 2 minus x, right? And those are the two curves that we get, and we could, obviously kind of do that. Maybe have to zoom in to make sure I'm on the right point there. But negative 1/4, valid answer. 1 is not showing up there as an intersection point, so we could kick 1 out extraneously that way, right? Or you can use their their algebra panel here to do it a little bit easier, or a little bit more, I think, explicit. I can't use x for this process, because I'm going to choose a variable. Use any variable other than x or y. So I'm going to use a. Then we'll come down here where I see x, and replace it with a. And it asks me to add a slider, so I'm just going to hit enter, and I'm going to do that. Now you see a slider is developed, and it's going to evaluate both those expressions, the left-hand side and the right-hand side of the equation, at any one of these values. Well, I can sift through there and find negative 0.25, or I can highlight that and just type in negative 1/4. And you see that it evaluates them and gives me the same result, right? So it tells me negative 1/4 is a solution. I can evaluate it at 1, and we see that it gives me different results, so 1 is not a solution. Okay, does that work? Okay, I'll show you how to do this on your TIA 384. You have to do this on the ACT. A couple different ways of doing it. Okay, first one, most direct one, is to take your solution and hit the STO button, and then hit X. And then I'm going to hit enter. And if I've done this correctly, it will just spit back the negative 0.25 that I typed in, right? If I've done it incorrectly, so the incorrect way of doing it is X, STO, negative 0.25. If you do it in that order, backwards, it'll just say error, okay? So then you just flip it. What you're storing it inside of has to come second. So I'm storing it inside X. So now if I just type in 2X, it'll evaluate 2x with negative 1/4 as the x value. Does that make sense? If I type in 1 minus the square root of 2 minus x, it will evaluate that at negative 1/4. And now you can see this. So this is the same thing that Desmos was doing, right? Okay. Another option. Go to y equals. Type them into y1 and y2. Okay? Go back to your calculator screen. I'm going to hit the vars key. I'm going to go over to yvars. I'm going to hit function. And this is going to be the way that I can recall y1 and y2 without having to type them in on the home screen. So I'm just going to hit y1. And right now, because I had inside here, I had y1 as 2x. This is representing 2x. I'm then going to say, well, plug in negative 1/4, and I can get negative 1. It'll evaluate that correctly. Okay, I think that's a little bit longer way because you got to find where yvars is. But now I can do the same thing with y2. Does that make sense? I think the fastest way, because you're probably going to graph these anyways, I think the fastest way is going to you got the y1, y2. I'm going to go to table set, which is the second window key. And usually these things are, they change depending on how you've messed around with your table. I'm not even going to focus on those. I'm going to come down here where it says auto and ask for the independent variable. Independent variable is your x. It's the one that does not depend on anything else. And I'm going to ask it. So I'm going to highlight ask, and I'm going to go to second table. And notice my table is not filled in, right? So I'm going to ask it some x values. I'm going to ask it 1 and hit enter. And you see then it's telling me 2 equals 0 essentially there. Well, that's a false statement, right? So 1 is extraneous. I'm going to ask it for negative 1/4. And there it evaluates both of them, and I get the true statement. So now negative 1/4 is my option, okay? If you don't do the independent variable set to ask, when it says auto, it's going to auto-fill your table, and that's probably what you guys have probably used the most often, maybe in Algebra 1 and Algebra 2, okay? Now you see that I actually had my delta table. You guys remember what delta stands for? In science or math? What's it stand for? Well, it is a triangle. What concept does it stand for? Change, okay? And change, mathematically or scientifically, refers to difference, okay? So what it's going to say is, right now we see my table. When I hit second table, the first value is going to be negative 1, and then it's going to change by 0.25. So then I'll see, negative 0.75, negative 1/2, negative 0.25, 0. Like that, okay? I think that's a little bit messier because you guys scroll through. Sometimes if you don't set your table change correctly, you might not find the solutions that you're trying to check inside there.
Both of them. Got both of them. I hear clowning.
All right, let's skip number 3. Let's get down here to example 4. What's different about this question?
Got 2 radicals.
2 radicals, okay? The idea here is when you have multiple radicals, okay, you are going to go through the process that we just went through multiple times, okay? So you're going to take your equation as multiple radicals, and you're going to isolate one radical. And then you use the inverse operation, do all the math that's involved there, and then you're going to get a line of work that has leftover radicals. But you should have one less than what you started with, okay? Then in that new line, you're going to isolate a radical. You can't subtract radicals unless they have the same radicand in there. Obviously, they do not have the same radicand. They would only have the same radicand there when x was equal to 0. Okay? So the process is then we isolate radical, simplify, isolate remaining radical, simplify, isolate a remaining radical, simplify, and keep doing that kind of tiered structure until all your radicals vanish. Okay? So, is the radical here isolated?
Yep.
Yep. Okay? So we're going to, right off the bat, just start squaring. So I'll square this side, and then I'll square this side. Squaring the left-hand side gives me 3x plus 1. Okay? Now the right-hand side, this is where we usually struggle. The right-hand side is saying this. The number one error people make is that they square the left-hand side, get 3x plus 1. They square the right-hand side and say it's 4 plus x plus 1. Right. Can't do that because you lose your O and I terms when you do that. Okay? So maybe writing out that way will be beneficial for us because now we can see that on the right-hand side, we're going to have 2 times 2, which is 4. We'll have this root times 2, which will give me 2 of them. We have this root times 2, which will give me 2 more. So I should have that, right? I add my O's and I's together. And then last times last, what's a radical times a radical? If they have the same radicand, it's just the radicand, x plus 1. Okay? Now, we generate more terms than what we started with, which isn't really anything that we want to kind of base our concept of the equation looking simpler off of. Okay? Just because we have more terms doesn't mean it's not simpler. We have less radicals now, right? We have less radicals, so that's why this is simpler. Okay? I'm going to isolate the remaining radical. So when I isolate the remaining radical, I'm going to subtract x from both sides, so I get 2x. I'll subtract 5 from both sides, so I get minus 4 is equal to that. Okay, at this stage, you can divide both sides by 4. You can isolate just the root. Okay, and there's nothing wrong with doing that. But think ahead. If you're going to isolate that root, the next thing you would do would square both sides, right? If I divide both sides by 4, because 2 is not divisible by 4, even though it's got a common factor, it's not divisible by it, right? I would have 1/2 x minus 1 over here, right? When I square this side, I'm going to have to square this side. Do you want to square fractions? No. Okay? So I always think ahead, and I'm going to leave that 4 there. Okay? If everything, if it's like 8x minus 4, absolutely I'm going to divide by 4. Okay? So if my information on the left-hand side were all multiples of 4, I will divide everything by 4. Otherwise, I'm leaving it where it's at. And when we leave it where it's at, we just got to be cautious that we understand our algebra. So we'll square the left-hand side. So that gives you 4x squared minus 16x plus 16, right? That's what the left-hand side turns into. And that's just foiling. Okay? The right-hand side. The right-hand side. Remember what we do with radicals and how we multiply radicals. If I had 2 radical 3 times 5 radical 6, you guys remember how you multiply those?
Yeah.
How?
Change them into
Nope. You just multiply. 2 times 5 is 10. 3 times 6 is 18, right? Then you could simplify, but that's all you have to do to multiply radicals. I made them up. So a lot of times, when we get to an algebra step, I'm trying to show you what to do. I will go to just an integer example to remind us of procedures. Because that's all x plus 1 is, right? X plus 1, if x was 2, isn't it 3, like I have up there in my example? If x was 5, isn't it like my 6 I have up there in my example? Does that make sense, everybody? So if I understand how to do the math with integers, I do the exact same thing with the variables. So when I look at this right here, this 4 times root x plus 1 squared, it really means that, right? So kind of drawing the comparison there. When we did this, we multiplied the numbers out front and got 10, right? Well, what are the numbers out front here? They're going to give me a product of 16, aren't they? Okay. Now, if I multiply that times that, okay, what's that going to leave me with? X plus 1. Now, I don't want to just write it that way, because when I read that, it's 16x plus 1, right? I want to put, because it's a quantity, I want to put parentheses around it, telling me I have 16x plus 1. And now I'm going to think a little bit. I'm going to foreshadow. If I divide everything by 16 to get the multiplier out there on the right-hand side to go away, do I generate fractions on the left-hand side? Yeah. They're not terrible fractions. It's 1/4. It's not a terrible fraction. But think ahead. If I distribute that 16 through, would you have a positive 16 on the right-hand side? If I go 4x squared minus 16x plus 16, distribute this through, you get 16x plus 16, right? Now, this is why I'm trying to think of two options here, either to divide everything by 16 first or to distribute the 16, because which one's going to be faster? What happens there when I distribute the 16? You get whole numbers, but what happens here? Those cancel out, right? You no longer have a constant in this problem. Okay? Move the 16x over then. And I get that. Now it's a quadratic that we should be able to factor, right? Both have 4x in them. So x is 0 and x is 8. Okay, now just be cautious, because we went through a lot of work, right? At this stage, we might have completely forgotten what we started with. But we started with an equation that had radicals, right? What do you always have to do when you have radicals? No. Check them. Plug them back in. If I plug 0 in, I get radical 1, which is just 1, right? Now over here, I'm going to have 2 plus. Now, just saying, it's not hard to do the math, but think about this. Does it really matter what I'm adding to that?
Nope.
It's going to be bigger than 2 when I add something to it, right?
Yep.
Is something bigger than 2 always going to be different than 1? Does that make sense? So I'm going to save myself a little bit of work. I already know that 1 and 2 are not equal, so 1 is never going to be equal to something like 2 plus whatever. Okay? So 0 is an extraneous solution. What do you mean, what if it's negative? Well, if it said 2 minus something, is that what you're saying? Then I would probably want to check.
So what if it's like 2 plus -1?
But it's not.
Okay.
Because I know a root is never going to be a negative result, right? Because if there's a negative underneath the root, then it's going to end up being imaginary, which again would be an extraneous solution. Now if I try 8, I get 24 plus 1, which is 25, right? Square root of 25? 5. And then 2 plus, it's going to be square root of 9, which is 3, right? Is 5 equal 2 plus 3? Yep, so that is a solution. Do not get, and even though you might see this happen a lot, if I give you 10 questions, 9 of them, you might check 0, and it'd be extraneous, and then you check 8, and 8 be the answer. Does that make sense? So you do that 9 times, and you're going to start training to yourself, well, every time I recognize that one's extraneous, the other one's the solution, right? But on that 10th one, they both might be solutions. On that 10th one, they both might be extraneous. Does that make sense? So please always check. Don't, because of previous problems, don't get yourself in a habit. A bad habit, at least. All right. You guys want to talk about one that has W in it, right? All right, let's jump down here to this one. Now, this is an example that is a radical equation. So we could probably solve this using our knowledge about radical equations. I want to solve it using what WebAssign said was like a capital W. I won't use a capital W because I think that's dumb. Now, when you do it in WebAssign, you have to, but you can make the switch on your own. This here is referred to as an equation in quadratic form. Remember, quadratic form is anything of this, right? Ax squared plus bx plus c equals 0. Now I'm going to rewrite that a little bit. I'm going to write it this way. Put parentheses around my variable part, and I put the exponent with 1, right, for the x, okay? Anything that is what we refer to as quadratic form. This is a root equation. This is not a quadratic. But everything that is quadratic or quadratic form, if I look at the exponents of the a term and the b term, they are in a 1 to 2 relationship, meaning that the b term, its exponent, is always half the exponent of the a term, right? Okay? At any time you get an equation where that is true, it's quadratic form. So I'm going to rewrite this. And it's not extremely evident the way they present it to me first. If I rewrite it this way, because that's what square root means, right? Square root means a rational exponent of 1/2. Are my exponents now in a 1 to 2 relationship? So we always want to think quadratic form. I'll write this for you. B term exponent is half a term's exponent. That's kind of the identifier for us to determine whether it's quadratic form or not. And you're going to have 3 terms, A, B, and C. Okay, so we've got that. So this is where we introduce what WebAssign is using as a W. I'm going to use something different because of the terminology that you'll use in the calculus course, and it's a terminology that we're going to use a lot in this course. It's called U substitution. Okay? So where we're using a U in your homework, it's a capital W. It can be any letter you want. Okay? It doesn't have to be U, it doesn't have to be W, it can be anything you want.